Welcome back, YouTubers. Now that we've got addition and subtraction of polynomials down, we're going to move on to multiplication. Now, I absolutely love algebra tiles for multiplying polynomials. These are where algebra tiles really shine, but only if you know how to use them properly. So we're going to start off with some pretty basic multiplication that I'm sure you've done before, and I'll show you how it works, and then move our way up to some bigger and badder things. So let's take just a simple one that we've done before, something you might have learned back when you were in about, let's say, third, fourth, fifth grade. Let's just take 3 times 2 and see if we can learn how to multiply that using algebra tiles. Now, multiplying by algebra tiles, what you always want to do is make yourself a little bracket box to start off with. Now, this is going to be our little division between the problem and the answer. The problem is going to go on the outside of the box, and the answer will end up on the inside of the box. So let's go ahead and get to it. Let's do 3. If I do 1, 2, 3 on top, it's going to line up right at the side, or at the top on the line, times 2. Just line it up right there on the box. Now, what we're going to do is try to make a perfect rectangle using our algebra tiles. So let's go ahead and throw this in there. On the inside, those guys will fit. Oh, there's one row. And then my second row will fit in there. And now, there we go. I've got a perfect rectangle that I made of this length and this width. As you can see, like I said, my problem is outside the box, and my answer is inside the box. 3 times 2 gives me 6. So I can go ahead and copy down my answer is 6. Now, some students always want to ask, what if I put it the wrong direction? What if I put the 3 on the side and the 2 across the top? Well, my box would have still fit in. It would just be reversed around. So it doesn't matter what direction you put it in. Now, I always like to pull these guys away so that I don't get them mixed up with the answer. Now, let's go ahead and think about what would happen if one of those had been negative. What about a 3 times negative 2? Well, in this case, I make sure that these guys are negatives, and in each single time that I put one in, I've got to consider, is it a positive or a negative? Well, positive 1 times negative 1 gives me a negative 1. Positive 1 times negative 1 gives me negative 1. Each of these has a positive on the left and a negative from the top, so they are each going to end up being negative. And then I peel these away and see that my answer is a negative 6. Well, then what if I'd done a negative 3 times a negative 2? Well, in that case, we would have a negative 3 times a negative 2, and now in this case when I'm filling in, I see, negative 1 times negative 1 gives me positive 1. Negative 1 times negative 1 gives me positive 1. So all of these guys would have been positives, and I would still end up with a positive 6 as my answer. Now, I know that is a bunch of easy math that y'all have seen before, and there's really no point in practicing it, but I just wanted to show you the basics of how that works and how I could even use it for my old skills I learned back in elementary school. What we're eventually going to start doing with it is, instead of doing 3 times 2 equals 6, doing things like 3 times x plus 1, and then seeing how would that fill in. Well, let's go ahead and do it. 3 times x plus 1. Now, in each case, I want to try and fill in shapes that'll fit into these corners exactly precise. Let's throw a 1 up in that corner. Now, while this one does fit to the left, it's too short for the one at the right. If I were to throw an x squared in there, we can see that one fits on the right, but it doesn't fit going down. This one, if I put it in going vertically, it doesn't fit either direction. But if I put it in horizontally, that one nestles in there perfectly with both the x on top and the 1 at the side. So I can just start filling these things in to see what will exactly fit. Now on this side, the same rule applies for this edge on the right hand as well. the 1 is going to fit in there perfectly. If I put in an x, again, it's not going to fit any direction. So put that one in this direction. 1, 2, 3. And there we go. Go ahead and pull your original problem away. And our answer is going to be 3x, 1, 2, 3x, plus 3. 3x plus 3. Now, I could do that with any size of thing that I wanted to. I'm going to keep them small so that we can make sure that they are able to fit on the screen. But what if, instead, I had done this? What if I had said 2 times 3x minus 4? Now that we have that negative sign in there, we've got to take that into account as well. Well, here's my 2, and here's 1, 2, 3. Oh, I may have made this too large. And then minus 4 is 1, 2, 3. Oh, looks like I did make it too large. And let's put a fourth one. Let's get another sheet of paper under there so we can see the color difference. 4. Well, now we start filling things in. Now that we have negatives to consider, we have to look at our signs. Positive times positive gives me positive. So these are going to fill in as positives all the way through. And now for my last bit, I see a positive on the left right here and a negative on top. Means that I'm going to have negatives as my answers. So let's go ahead and fill those guys in. And hopefully I won't fall off the edge as I'm trying this. Always trying to make a perfect rectangle as I go through. Peel off the original. And I'm left with 1, 2, 3, 4, 5, 6 x's. And then 1, 2, 3, 4, 5, 6, 7, 8, and a negative 8. Now that's our basics of how to multiply. We'll get into actual real multiplication of binomials on the next video. But let me show you the algebraic way of doing this without the algebra tiles. All we're doing is distribution. Well, 3 times x gave me 3x. 3 times 1 gave me 3. We have to multiply the number in front by everything on the inside. Here we've got 2 times 3x gives me 6x. And 2 times negative 4 gives me negative 8. So using that same distribution tool, I could multiply anything I wanted to, even stuff that would not have fit because it's just physically too big to do with algebra tiles. What if I wanted to do 5x minus 10, all of that times 7? Well, 7 times 5x would be 35x. 7 times 10 would be 70. We have to check for that negative. Positive times negative makes me negative. And again, that's one that you could do using algebra tiles, but since it's such a large number, it'd be pretty hard to try and facilitate. So we'll move on the next video to multiplying more complicated things using algebra tiles.